Bismillahirrahmanirrahim. Hello everyone and good afternoon. I hope you had a good day. How was your day? Is everything okay? Uh, Again, I made change to some slides of the PDF, so I have to upload it again. I'm going to upload the new file, so I think it takes 2 or 3 minutes. I hope no more than 3 minutes. So until the file is being uploaded, do you like football matches? Do you follow football matches? Uh, you know, Unfortunately, a few days ago, our football team, Iranian team, drew with South Korea, 1-1 drew. You know, and however, I hope that the Iranian team will advance to the World Cup. We are still the first team in the group, and yes. What do you think about the Iraqi team? Do you hope to advance your national team to World Cup? I think you do not have an easy way. Your team must be better than Syria, Lebanon, and the UAE. Hmm. I don't know. I hope that the Iranian and Iraqi football teams will advance to the World Cup from this group. And it's possible, I think. You had a good match against Korea, South Korea. But there is still a lot of match remaining. You know, if you win the other matches, so probably you can gain enough points to advance to the World Cup. Thank you. Okay. And chapter 1, the newest file was uploaded successfully here, and I'm waiting to see it. Oh, it took too long. Well, okay, as you can see, it's the newest file, and let me zoom it. So, where were we? Where were we? We talked about examples of distributed system, and did we talk about example of distributed systems? Goals and definitions, bandwidth, latency. Was this our last slide we talked about? Well, so we talked about some examples of distributed systems in the last session, and I suppose today we will have two sessions, and our next session will start immediately after this session, I think. And so, well, after the football discussion, we are ready to continue the discussion about distributed systems. In other class, we used a new method. I noticed that a large number of students have problems with English. They also had problems with the Persian language. Therefore, I decided to speak Persian, and one of the students who was fluent in Persian translated my speech into Arabic. Got it? So how can we try this method in this class as well? If you agree, we can do the same. Understand? Not Persian. Let me do it as a poll here. We can use adding new poll. So the question is that which option do you prefer? So please answer. There are two options here. We can stay in English. I can continue the class in English, and the other option is about speaking in Farsi. I can speak in Farsi, and one of your friends can translate my speech into Arabic for other students. So please participate in this poll. It's an election. Other students, please vote. All students must vote. There are 22 participants here. Most of the students has not voted. Wow, it's a big distance between you and the other class students. Almost all of them selected the option 2. They wanted me to speak in Farsi, and I asked one of their friends to translate in Arabic. But in your class, it's completely different. Most of you interested in staying in English. Why other students do not participate? زید حیدر هاشم الخیاط مصطفی محمد جاسم. Where are you? Sahad Muhammad Abdullati Ahmad Khalaf Ahmad. Where are you? Please participate. مصطفی صالح محسن الساعدی عقیل فاضل حسین الکایشی محمد جعفر یاسین. Okay, I know you don't understand Farsi, but one of your friends that he is fluent in Farsi can translate my speech into Arabic. Okay, it's on you. What do you prefer, stay in English or speak in Farsi and translating it to Arabic? Okay, most of students selected option 1, stay in English. So we can continue our class in English. Zaid Haider translated to Arabic, so please participate in the poll. in this voting. You can vote it. No one selected the option 2 yet. But 12 students selected option 1, so most of the students selected this option, and we can continue our method. Okay. Well, and we are here. In continue of examples of distributed systems, we have a very good and shiny example here, distributed multimedia systems, or DMMS, distributed multimedia systems. Mr. Muhammad Jafar, I said the second option is about to teaching in Farsi. I teach in Farsi, and one of your friends who can understand Farsi can translate it to Arabic simultaneously, approximately simultaneously. Is there anybody who can fluent in Farsi? Who is fluent in Farsi in this class? Who is fluent in Farsi, Persian language, I mean? I want to talk to him or her. If there is a student who understands Farsi, please raise your hand. I want to talk to you. No, the final exam could be in English still. It's not about final exam, okay? Don't worry about final exam. No one? So, if there is not any student who can understand Farsi, the option 2 is being ignored. Okay. So, let me continue the lesson. I talked about distributed multimedia systems as another example of a distributed system. The appearance of distributed multimedia systems, or DMMS, was about 30 years ago. It was about video conference, in fact. And you know what is video conference? A distributed multimedia system combines a variety of multimedia information resources over a network into an application used by the client. So, as you may guess, the system is based on the interaction between the user and the application. Interaction between the user and the application. Here you can see a simple architecture of DMMS. As it is shown, several multimedia resources and clients are interconnected through a network. And I suppose You will not be surprised if I say that we are using Dmms right now. We are using Dmms right now. Currently, you and me are using a Dmms. Yeah, if I'm able to share this picture for you and if you can see it while hearing my voice, it is because of Dmms. Got it? Clear? Good. So about Dmms, goal and definition. What is the goal? Simplicity in and of itself. We want and need high quality, reliable, interactive multimedia. So please remember that the simplicity is as important as the quality and reliability in Dmms. But what is reliability? You know what is simplicity? It must be. We must be able to create a Dmms easily and to use it to share video and voice. It's okay, but what about reliability? Have you heard about it? What is reliability? The trust. Not exactly. I'm looking for something else. Trust. We say قابلیت اطمینان if it could help you. قابلیت اطمینان or reliability. No, it's not about authentication. It's not about authentication. Relation between multimedia. No. The probability that the system will work without failure. It's the exact definition, but please do not copy paste from the internet. If you ask me what is reliability, I will simply say that it expresses the probability of success of a task as a percentage. For example, what is the probability that the plane will fly without an accident? The answer is a number in percentage, so it is the reliability of the fly in our example. The reliability is a very main concept in computer science, and I can suggest you, if you are interested, you can select this area to go in depth for your dissertation, reliability, but you need to pass a course with the name of dependability and reliability in master's degree, and in that course you can learn the reliability and many aspects of reliability. It's very interesting area, but it depends on you. If you are interested, you can go on. Okay. It's not about dependency, it's about dependability. Dependability and dependency are two different things. dependability. Reliability is one requisite of dependability. Well, now let's go to some important definitions about DMMS. One thing that is very important in DMMS is bandwidth. What is bandwidth? I'm sure you know what is bandwidth. Please tell me. Are you Googling it now? Do not Google it, please, please. Tell me what you think about it, what you know. Amount of data transfer through network. Maximum amount, yeah. It's better. Maximum amount of data transmitted. Yes. Yes, exactly. It is the maximum rate of data transfer across a network. And yeah, I think you completely know what is the bandwidth. And the other definition is about latency. The latency is not only important in DMMS, but also in all distributed systems and applications. So what is it? What is latency? Yeah. I said it's important in all DMMS applications. Why? Because in distributed systems, a network is used to connect machines, and in a network, latency is an important definition, you know. However, latency in DMMS plays an important role due to the inheritance of DMMS. What is the inheritance of DMMS? Why in DMMS latency is an important concept or definition? Because DMMS, distributed multimedia systems, are inherently real-time, and in real-time systems latency is very important. So a new question is, what is a real-time system now? What is real-time system? Think about it. It is a very important and interesting area too. Real-time system. Don't worry, I will give you some information about it soon. So have task must be executed in a given time. Yes, exactly. We will talk about it in detail later, okay? And the other definition is about loss rate. Loss rate, have you heard it? If you have passed network systems in your bachelor, so you will be familiar with these definitions: loss rate, latency, bandwidth. What is loss rate? Amount of data loss in transmission media, the rate of loss in time. Loss rate in DMMS, distributed multimedia systems. Distributed multimedia systems like watching a football match through internet. So it's a distributed multimedia systems. And loss rate is about acceptable drop frame ratio. I mean, the acceptable frames that will be lost or can be lost. It's about ratio, so we can define it with the number of frames that are acceptable to be missed in every second, in per second, for example. If you are watching a movie or a football match with 24 frames per second quality, so if, for example, if you miss 2 frames in every second, it would be acceptable for you, okay? So it's the loss rate for this example. And quality of service management, or QoS. Quality of service is indeed a negotiation and allocation of computing resources in DMMS. So it's about negotiation and allocation of resources. And DMMS is a revolutionary in challenging some manufacturers to think again about many customer and consumer devices. Manufacturers to rethink many consumer devices. For example, for decades, the main home entertainment device has been television. You know, the main entertainment home device has been television. But what about the future? What do you guess? Television, computer, game console, laptop, or tablet? Who knows? It is the meaning of a rethink, I said. Got it? Do you want me to re-explain? I said for decades the main device for home entertainment has been television, you know, okay? But with appearance of Dmms, it is a challenge for the future. It needs to think deeply and guess what device would be the main entertainment device in home. So yeah, okay, I repeat it again. For some decades, the television has been the main home entertainment device for decades. But now, after the Dmms appeared, it is a challenge to know in the future which device would be the main home entertainment core. Computer, television, game console, laptop, tablet, who knows? It's a challenge. Okay. Why it's a challenge? Because of Dmms. It's not easy to say the television will stay as the main home entertainment device in the future. We cannot be sure for this. So, before I explain about real-time systems, let me talk to you about some important points here. Honestly, I had several requests by email for accepting supervising students' dissertations. However, due to my time limitations, I cannot accept all the requests. And I also must say that my research interests are as follow. You can see these topics, which are my research areas. I strongly recommend you to select the right person, the right professor for your dissertation supervisor. If you are interested in some topics, so please go to request from someone who has knowledge about that topic. Otherwise, he cannot help you, and you are the only person who must do all the work, and it's difficult for you. So these are the list of my research interests that I can help you if you are interested in these topics. I have some information about it. Okay, so I can help you. Otherwise, I cannot help you. If you are interested in image processing, I cannot help you. I don't have enough information and knowledge about it. The first topic is about real-time systems and real-time scheduling. I'm not sure if you are familiar with this topic or not. It's about real-time systems. And the second one is about multiprocessor scheduling. Embedded systems, or indeed critical embedded systems, is another one. Dependability, reliability, and fault tolerance, if you are familiar, could be a good topic. FPGA and scheduling hardware tasks on FPGA, and scheduling hardware and software tasks on a hybrid environment containing CPU and FPGA. And lastly, bioinformatics, especially phylogenetic trees. These are main topics of interest about me. So if you are interested in one of these topics or you are familiar with them, we can talk about your dissertation. Otherwise, I'm afraid I cannot. Bioinformatics is about some algorithms in biology, computational algorithms in biology. For example, to find some patterns in DNA sequences or patterns in RNA sequences in the cell. And also phylogenetic trees. I have some experience about it. I had some researches about it, phylogenetic trees. So it's about making a tree of ancestors of animals or plants. Bioinformatics, in fact, is a major between two sciences, between computer science and biology. So you have to have some information on biology. It depends on you if you are interested. So you can study in biology, especially cell biology, to gain some basic and fundamental information about cell, DNA, RNA, and their patterns and the elements that the DNA is consist of or constructed from. And then you can learn some algorithms about computational biology. So please keep in mind that only request the right person to accept your dissertation supervising. It's very important for you, and okay. And now, distributed real-time and real-time systems. Firstly, remember the definition of distributed system. What is distributed system? Who can tell me? Quick. I said you can memorize it. You should memorize it, or you must memorize it, the definition of distributed system. So, what is distributed system? Independent computers, they're connected together through a network, and users must see this system as a single coherent system. Okay, good. A distributed system is a collection of independent computers connected by a network in which users see this system as a single coherent system. But real-time systems are those systems that not only the correctness of execution is important, but also tasks must finish their execution in a given predefined time. In a given predefined time. I mean, in this system, we have deadline for tasks. Tasks must finish their execution before their deadlines. And do you know what is the deadline? I said, yes. Yes, it's obvious. I think you know the meaning of deadline. Deadline is a predefined time. Predefined, it means we define it before the execution of the task. It is a predefined time that tasks must complete their execution in that time. For example, I upload a homework on Darsa. It's an example, okay? And I say that you must do your homework before Friday. Okay, it's the deadline. So, two concepts are important for me. The first concept is that you must do your homework correctly. And the second concept that is important is that you must do your homework before Friday. If you do your homework, for example, 10 days later, it is not acceptable for me, even though it would be correct. So it's the deadline, and in real-time systems, the correctness of task execution is as important as its deadline. Yes, we are in real-time system. In fact, our world and our life is real-time. No, it was example. It was an example only, okay? There is no homework for you. So, what about task scheduling? Do you know what is task scheduling? Or is there a good student to briefly explain task scheduling for me? If you remember, in operating system course in your bachelor, you passed it, I'm sure, operating systems. In bachelor, we had some scheduling algorithms, such as FIFO, first in, first out, or first come, first service, and also round robin based on slack times. When we have limited resources, and also we have many requests, so we have to schedule. For example, we have only one processor, but we have many tasks that they want to be executed. and the processor can only execute one task in a time. So we must schedule. For example, we can select task 2 to be executed first, and then when it finishes, task 3, and then task 4, and so on. So it is the meaning of scheduling. There are limited resources and there are many requests. It is our need to schedule. It's not only about processor, about access to the disk, access to the database, or many other things. Everywhere we have some limited resources and many requests, we must schedule, and we must select some priorities to execute it first. So FIFO is a scheduling algorithm based on queue, first in, first out. Round robin is based on slack times. First in, last out, it's not scheduling algorithms. It's about a mechanism used in a stack. First in, last out is a mechanism used in a stack. It's not scheduling algorithm. Okay. But in real-time systems, we need a new algorithm to schedule real-time tasks. Why? Because tasks have deadlines. So there are some main properties in real-time scheduling. The first property is about release time or ready time. Release time or ready time is the time at which the task is ready for processing, or the time that task arrives. It means it requests for processor. Deadline, we talked about it. You know what is the deadline. And worst case execution time. Worst case execution time is the maximum time taken to complete the task. For example, we have a task that at most needs 3 time units to complete its execution. It's the worst case execution time. In other words, we can be sure that if we assign the processor to this task can finish its execution in that time or before this time. Period in periodic real-time systems is about the times that the task repeatedly requests to be executed. In periodic tasks, jobs are released at regular times intervals. These time intervals called period. For example, assume that in airplane there is a system that calculates the pressure of the cabin. The pressure of the cabin. For example, every 2 seconds, this task must calculate the pressure. It is repeatedly executes. Every 2 seconds, this task requests to be executed. So this task is periodic and the period is 2 seconds. If this task needs at most 100 milliseconds to be executed, then the worst case execution time of this task would be 100 milliseconds. Worst case execution and deadline are two different properties. Let me back to my example. In airplane, there is a system to calculate the pressure of the cabin. Okay. This task is released every 2 seconds. Every 2 seconds. It means the task arrives every 2 seconds. It means the task requests to be executed every 2 seconds to calculate the pressure of the cabin. It is its period. But consider that this task, after starting its execution, takes 100 milliseconds to finish its execution. In 100 milliseconds, it can calculate the pressure of the cabin. So it is the worst case execution time, or execution time in simple. Okay, so execution time must be less than the period and the deadline. What is the deadline? Usually in periodic tasks, the deadline is equal to the period. So in our example, the period was 2 seconds, so the deadline is 2 seconds too. It means in every 2 seconds, the task arrives to calculate the pressure of the cabin. And it needs 100 milliseconds to be executed, to finish execution. But it means finish its execution before the deadline, before the next task arrives. Okay. Good. So, it is an example of scheduling real-time periodic tasks. It's a simple example. We do not focus on real-time scheduling in this course. Okay, so I want to give you some basic information about real-time scheduling, real-time systems, and then you can find the differences between real-time systems and distributed systems. So it's an example, just example. It's not our main course. By looking at this picture, we easily see that there are 3 tasks. There are 3 tasks. These 3 tasks are periodic. It means they are repeated to execute it in predefined times. Assume task 1 is a task to compute and monitor the pressure of the cabin. Okay. It executes every 4 milliseconds or 4 time units. Every 4 milliseconds, okay? And the execution time, worst case execution time, is 1 millisecond. So the period for task 1 is 4 milliseconds. The deadline is equal to its period, and it is 4. The execution time is 1. So every 4 milliseconds, task 1 requests to be executed. Every 4 milliseconds. And it takes 1 millisecond to finish its execution after it starts the execution. And it must finish its execution before the deadline, before the next request arrives. The same is for task 2 and task 3. Task 2 arrives every 5 milliseconds. You know, at time 0, at time 5, at time 10, at time 15, and so on. and its worst case execution time is 2 milliseconds. It means it needs 2 milliseconds to finish its execution. For task 3, this task arrives every 7 milliseconds at time 0, at time 7, at time 14, and so on. T3 needs 2 milliseconds to complete its execution too. So there are 3 tasks. They are real-time, they are periodic, and we know the execution time and the deadline and the period of every task. Clear? No sound? Can you hear me? Okay, good. So we have one processor only, okay? Suppose that we have only one processor and we need to schedule these tasks. Assume these 3 tasks request or arrive at time 0. Simultaneously request for processor. We have only one processor, so we have to select one task to be executed first. The first selection is task 1 here. So task 1 starts its execution at time 0. Here. Task 1 starts its execution at time 0, and it needs 1 millisecond to complete its execution. So at time 1, task 1 completes its execution. Now, processor is idle. We must select between task 2 and task 3. They are waiting to be executed. We must select one of them. We select task 2 to be executed. So task 2 starts its execution at time 1. It needs 2 milliseconds to complete its execution. So at time 3, task 2 finishes its execution. At this time, processor is now idle. How many tasks are waiting for execution? How many tasks are waiting to be executed here at time 3? One task, and that is task T3. Okay. Task T3 starts its execution at time 3. It needs 2 milliseconds to finish its execution. So at time 5, it finishes its execution. At time 5, again, the processor is idle. How many tasks are waiting to be executed at time 5? Exactly at time 5, how many tasks are waiting to be executed? 2 tasks, exactly. T1 and T2. T1 arrived at time 4. You can see here. T1 arrived or requests at time 4. T2 arrived at time 5 here because its period is 5. So at time 5, when T3 finishes its execution, we have 2 tasks waiting to be executed. Which one is better to select? Which one do you select to execute here? Task 1 or task 2 at time 5? Why task 1 is better to start its execution here? Less time or short time, or better to say shorter deadline. Its deadline is shorter, yes. Task T1 has a shorter deadline, so it's better to select task T1 to start its execution at time 5. At time 6, T1 finishes its execution, and now T2 can start its execution, and so on. It is time scheduling or task scheduling, sorry. It is real-time task scheduling based on deadline. It is called EDF, earliest deadline. Miss deadline. I suppose I disconnected for a few seconds. Okay. So as I said, it is a real-time scheduling algorithm. It's a simple algorithm called EDF, earliest deadline first, and I'm sure that now you know what is real-time systems and what's the difference between real-time systems and distributed systems. So distributed systems and real-time systems are two different areas, and okay, it's enough for this session. The next session will start about 45 minutes later, and if you don't have any problems and questions, we can finish this session now. Okay, I will see you 45 minutes later. Bye.